Alrighty, so here are some example problems to show you how to actually evaluate trig functions using the unit circle. We're going to start off with a mix of sine, cosine, tan mixed with either radians or degrees. Okay, so again, we want to remember that we associate, I should probably just jot my formulas down here. I know that sine of theta equals y, cos of theta equals x, tan of theta equals y divided by x, or sine over cosine. So really when we're finding sine of 60, first thing we want to do is look for the angle 60 degrees. Bam, found it right there. And then I'm looking at the ratio of sides, right? Not the angles, because what should come out of this is always a ratio of sides. You put in an angle, what comes out are sides. And now I just have to remember, well, is sine the x value or the y value? And you'll see here that it's in fact the y value, right? And so really this will just equal the square root of 3 over 2. So it's really just knowing where to look and how to use the unit circle about this. So take a look at this, cosine of pi. We got to find pi here. This is in radians. There's pi. And then again, cosine of theta is the x value. So we put in pi, we get out an x value of -1. And that would be our answer. And then we got tan of 5 pi over 6. All right, well, here's 5 pi over 6. Tan is sine x, y divided by cosine x. So this is 1/2 divided by -√3 over 2. We obviously don't want to keep it like that. So when you're dividing by fractions, we want to do keep, change, flip, or same, change, flip, however you learned it. Either way, you're keeping the numerator, changing the division to multiplication, and flipping this denominator. It doesn't matter where you put the negative. It's going to work itself out. And then you multiply across. 1 times -2 is -2 over 2 times √3 is 2√3. Now, typically, we don't like to have this radical in the denominator, but we're not going to focus on simplifying that right now because I'd prefer we just know how to evaluate trig functions using the unit circle, okay? And so we could stop here. So that's when we are just doing our basic trig functions, right? So let's take a look at when we've got our reciprocal trig functions. Again, it might be helpful to have the formulas down. We know that cosecant of theta is paired with sine, so it's really just 1 over y. Secant theta is 1 over x, and cotangent of theta is x divided by y, okay? Now, you can think of it this way, but I know that these are my reciprocal functions, so my answers for these questions are really just going to be the I'm having trouble spelling this, reciprocal. They're just going to be the reciprocal or the flip of whatever our ratio sides are. So if you want to think of this as sine of, 60, but then flip your ratio of sides, that's usually how I do it. So either way, I'm looking for the angle 60. Find it right here. And then since I know cosecant is associated with sine, I'm looking at the x value. What I'm doing is I'm taking this √3 over 2, that's my y value, and I'm putting it in the denominator. You can't see that. 1 divided by √3 over 2, right? That's the formula, cosecant 1 over y, where this is our y value, right? Now I'm going to do keep, change, flip, and I'll show you it's going to work out to be just the reciprocal of √3 over 2, aka 2 over √3. Okay, and so from here on out after this example, I'm just going to flip our coordinate point because it makes it a lot easier. But I'll go ahead and show you. You're going to keep, change, flip. So you keep the numerator, change the division to multiplication, and flip the denominator. And like I said, if you multiply across, this is over 1, you will get 2 over √3. Okay, we can keep doing that. What is secant of pi? Well, I got to find pi. That's right here. Secant is associated with cosine. That's -1. Now this is negative 1 over 1, right? And so if I were to do the reciprocal of that, it'd just be the same, negative 1. We can look at cotangent. It's just x divided by y. So cotangent of 5 pi over 6 is here. So x divided by y. We actually just did tan of 5 pi over 6 in the previous example. And we got negative 2 over 2 root 3. So if this is what tan of 5 pi over 6 equals, then the reciprocal, right, is just going to be the flip of this. It's going to be 2 root 3 over negative 2. Now, if that's not comfortable for you flipping it, then just use this formula, do the keep change flip that we do, okay? Either way will work fine. All right. Now, the last piece of this, before you guys go on to your practice, is what if they're asking for you to evaluate one of these, angles, but the angle does not fall on the unit circle, 390, negative pi over 4, 630, right? What are we going to do? You have to first make it fall on the unit circle. And the way that you're going to do that is you're going to find a coterminal angle, okay? As a reminder, a coterminal angle, all you're doing is either adding or subtracting 360 or 2 pi, depending on if it's in radians or degrees. Now, for this first one, what is sine of 390? Well, I want exact answers like we've been getting this whole time. Now, 390 I know doesn't fall in my unit circle, right? The highest it goes is 360. So that means that 390 is more than 360, right? Which means you go 390 and then a little bit more, okay? So you have to think, are you going to add 360 or subtract 360 to find your new coterminal angle? So it has the same ending and starting place. Well, since it's bigger and I want it to fall in the unit circle, I need to subtract. So I'm going to take 390 and I'm going to subtract 360. Okay. And it's pretty obvious what you'll get here is 30 degrees. Okay. So another way of thinking about the question sine of 390 is, well, it's really asking you also sine of 30 because it's falling on the same place. 390 is 360 degrees plus an extra 30, right? Except you see it still ends on the same place and it started again on the same place, right? So sine of 30 and sine of 390 are going to have the same ratio of sides, the same output value, right? And again, it's just the y value. So y value here is 1/2, and that would be our final answer, okay? All right, we can look at this cosine of negative pi over 4. Well, negative pi over 4 is not on the unit circle. You can think of it as going this direction, right, by pi over 4. That's another way of thinking about it. So you say you'll end up right here. But if you're not comfortable with that, right, we need to add 2 pi to this. So it will fall on the unit circle, okay? Again, this is 2 pi over 1. Now I need a common denominator, so I'm going to multiply this and this by 4. This becomes a 4. 2 times 4 is 8. And then you'll get 8 plus a negative 1 pi is 7 pi over 4. And again, what do you notice, right? It ended up right here like we thought. So really what this is asking for is cosine of 7 pi over 4. And again, cosine is just the x value, so our answer here is root 2 over 2. Okay? And this last one, tangent of 630, okay? Tan of 630, well, that's clearly above the unit circle, so I'm going to take 630 and subtract 360, and I get 270. Does that falls on the unit circle? We're good. Now, if it doesn't still fall in the unit circle, keep subtracting or keep adding 2 pi or 360 until it does fall in the unit circle, okay? And 270 is right here, and so we're doing y divided by x, so y negative 1 divided by x of 0. Uh-oh, 0 in the denominator. That's okay. All this means is our answer is undefined. There is no tangent value. Okay? Alrighty. So you should, let me just go through a few key takeaways here. We can use the unit circle to evaluate all 6 trig functions. They will give us the exact value, okay? If the angle does not fall on the unit circle, then you need to find a coterminal angle that does fall on the unit circle, and then evaluate using your unit circle. And then again, the last piece here is when you're evaluating reciprocal trig functions, so like cosecant, secant, and cotangent, the ratio of sides is just the reciprocal of the ratio of sides for sine, cosine, and tangent. Okay? All right, good luck on the practice problems. We'll have a couple more videos after this. I hope your spring break is going well.